Okay, 2017, number 1. We have a tank that's 10 feet high, and they give us a table with the area of the horizontal cross section at different heights. A of H is measured in square feet, and A is continuous and decreases as H increases. And there's our values of A of H in the table. So part A, left Riemann sum, 3 subintervals indicated by the data in the table to approximate the volume of the tank. Remember, volume is basically cross-sectional area times the height. So, left Riemann sum, left rectangular approximation. So our delta x, or our base for our first rectangle, is from 0 to 2, so it's 2. And our height, we use the left endpoint, so times 50.3. The next rectangle from 2 to 5, the delta x is 3, times the height, the left endpoint, is 14.4. And the last rectangle from 5 to 10, delta x is 5, times the height, which would be the left endpoint, of 6.5. We do the math, and it gives us 176.3, and its volume, so it's cubic feet. Part B, does the approximation overestimate or underestimate the volume? And explain why. Well, the question told us that A of H was decreasing. So we have a decreasing function, and as you can see in the little diagram I drew, when we have a decreasing function, LRAM is an overestimate of a decreasing function. You don't have to draw the little diagram, I just drew it to help you out. Part C, okay, the area is given by that function. Find the volume of the tank and indicate units of measure, so we just have to integrate that function. And for this, we could just use the calculator. We don't have to show the work. I do, however, think on the exam in May, because the graphing calculator is not required, they will give a function that is integrable. Okay, that you will be able to do the integral without it being too crazy. So just something to look ahead. And then part D, water's pumped in when the height of the water is 5 feet. The height is increasing at the rate of 0.26 feet per minute. Using the model for part C, find the rate at which the volume is changing with respect to time when the height is 5 feet and indicate units of measure. Okay, so H is 5, dH dt is 0.26 feet per minute, and we know the volume is the integral from 0 to h of f of x dx, or f of t dt. Remember, we're integrating our variable is h, so that's our upper bound, so we put in a dummy variable, x or t or whatever. And now we're looking for dv dt. Well, when we take the derivative of this, we get dv dt is just f of h times dh dt. So we know we're looking at 5 feet, so it's f of 5 times, we know dH dt they gave us is 0.26, and again just sub 5 into the function for f, so 50.3 over e to the 0.2 times 5 plus 5, and there we go, we get 1.694 cubic feet per minute. Okay, it's volume, remember it's dv dt, volume per time. So volume is cubic feet, and we know from dH dt the time is being measured in minutes.